Welcome friends. Let us continue to study about the air compressor on my YouTube channel. Kindly like, share and subscribe my YouTube channel. In today's lecture, we are going to study about the construction and working of dynamic pressure compressor, and particularly in that positive displacement type dynamic pressure compressor. And we are going to study today about the Vane type compressor. So this is the animation for the Vane type compressor. The construction and working of the Vane type compressor, it is similar to the Vane type pump. Construction. The construction is similar to the Vane type pump. It contains a rotor mounted on a shaft of electric motor. So it has a rotor which you can see here with the light yellow color, and it is mounted on a shaft, and the shaft is connected to electric motor. On a periphery of rotor, grooves are generated or there. So you can see here on the periphery of rotor, the grooves are there. Here in the animation you can see 5 grooves are there. Sliding vanes are arranged in each groove with the spring. So here you can see the sliding vanes are attached or connected or inserted in a groove, and at that end the springs are located. Thus when we press the sliding vane, it moves inside the groove and comes out when we release the pressure on it. The rotor is placed in the casing eccentrically. It means when the rotor is connected to the outer casing, there is a blue color, the center of both, that is the casing and the rotor, are not same, and due to that there is a non-uniform gap between the rotor and casing, and there is a non-uniform gap, and due to that when the rotor rotates and when there is a gap between the rotor and casing, the vane will come out, and when there is no gap, vane will insert into the gap. Sliding vane always in contact with the casing. At one side there is a suction and another side there is a discharge. Working. As the electric motor rotates, rotor also rotates, and air enters the compressor or the blower. Air is entrapped between 2 vanes and a casing. Thus the entrapped air has to rotate and move along with the rotor from suction to discharge section. Now when air moves from suction to discharge section, gap between the rotor and casing also decreases, and thus the air is compressed. Compressed air comes out from the discharge section. Let us see exactly how it works. So you can see here suction, air is entered at the suction step. So there is the horizontal line indicates the air has entered. In this there are 4 vanes. In particular this kind of vane compressor, to explain you. It moves in a anti-clockwise direction. Now when the rotor moves in anti-clockwise direction, air which has entered previously, now it is entrapped between 2 vane, casing and a rotor. So the horizontal line indicates the air has been entrapped between 2 rotor, casing and a rotor. Now as the rotor again rotates in anti-clockwise direction, you can see here now air has to come here. Now here you can see the gap is less, and as the gap is less, the air is compressed. So compressed air then comes out from the discharge section in the next when the again rotor rotates. So again when rotor rotates from the discharge valve or discharge place, the compressed air is taken out. So this is how the Vane type compressor works. This is the single stage vane compressor, and this is the double stage vane compressor, in which the air is compressed in one vane compressor, then after it enters into the another vane compressor where it is again compressed, and then it is taken to the storage. So it is known as a single stage and double stage Vane compressor. Advantage and disadvantage of Vane type compressor. Advantages: it creates a good vacuum for a suction. Vane compressor works well with the continuous air supplied. High pressure and high power compression are possible with the Vane compressor. Vane compressor have a longer life and they are ideally suited for the moderate pressure using application. Disadvantage: the vibration happens during the reciprocation of the cylinder. Because of more number of moving parts, maintenance cost is high. Application: they are used in agriculture for operating farm equipments, material conveying. Used in auto body paint shop for paint pump operation. Used in tire and wheel shop for tire inflation. Used in dry cleaning. Used in operation of air knives for the cutting and peeling. It is used in welding operations and air operated metal and woodworking tools. Now we are going to study the difference between the reciprocating compressor and centrifugal compressor using the different criteria. Discharge pressure. In reciprocating compressor, discharge pressure can be high up to 1000 bar, but in centrifugal compressor it can be low up to 40 bar. Discharge. The discharge is low in case of reciprocating compressor, but in case of centrifugal compressor, discharge quantity is high. Flow. In reciprocating compressor, flow of air is non-continuous, while in centrifugal compressor it is continuous. Speed. In case of reciprocating compressor, speed is low, while in case of centrifugal compressor, speed is high. Lubrication. As it contains the, you can say, more moving parts, the lubrication system is complex, while in case of the centrifugal, lubrication system is simple. Size. For same discharge, same quantity of air to be discharged, the reciprocating compressor is of larger size, while in centrifugal compressor is of smaller size. Maintenance cost is more in case of reciprocating compressor and it is less in case of the centrifugal compressor. Volumetric efficiency in case of reciprocating compressor is less, while in case of the centrifugal compressor it is high. Kindly ask your queries in the comment box. Kindly like, share and subscribe my YouTube channel. Thank you.